Hi everyone, welcome back again to Mathematics for Engineering 3. Today is chapter 4 and which is the systems of linear differential equations. And today is section 2, point 2, part 2. Okay, so we're gonna be talking about the case where we have repeated roots, case 2. Okay, so let's start. In the previous video, we looked at the repeated roots, right? When 1m can give you multiple k's, right? For example, if you can get, m1, you can get k1, k2, k3 to kp. Okay, and that's the first case. Okay, and this is the second case where 1m only give you one eigenvalue k1. Okay, it only gives you 1k. So in that case, you need to find k2, k3, k4 until kp, right? Because you have m1 repeated p times. So you need to have p solutions. You need to have p solutions, right? You need to have p solutions. So if it's repeated p times, you need to have p solutions. But if for 1m it gives you only 1k, so you need k2, k3 until kp. Okay, and how to do so? We would start with k1. We will start with k1, and then we look at this, we find k1 with this equation, right? We've done that many times. A minus m1i k1 equals 0, and that is when we obtain k1. And once we get k1, we have only 1k. If we have pk's, that's it. That's the previous case 1. But this is case 2, when we have only 1k. So if we have 1k, you can find k2 by take this 1k here, the k1, and then you use the same m, which is m1 here, and then you can obtain k2. Okay, and again you put k2 here. Okay, you put k2 here, and again guys, you use 1m again, and you will obtain k3, and so on and so on. So you would get kp. So in that case, you can get k1, k2, k3 until kp. Okay, and the first solution is x1 equals k1e to the m1t, and that is the same as the previous section, right? And the second solution is a little bit different. It's not k2e to the m1t. No, it's k1 k1t and then k2 e to the m1t. Okay, and that is x2. And similarly, x3 would be k1 t squared divided by 2 fact plus k2 t plus k3 and e to the m1t. Of course, if you want to write down k4 here, x4 here explicitly, it would be k1 t to the 3 divided by 3 fact plus k2 t to the 2 divided by 2 fact plus k3 t plus k4. It would be the big K, sorry. k2 t squared divided by 2 fact plus k1 t plus plus k3 t plus k4 and then e to the m1 t. Oops, sorry. And that is m4 if you need one. Okay, if you need x4, sorry, if you need x4. And this is the general form. Okay, so basically if you need x4 or if you need x3, you begin with k1 and then t to the p minus 1. So if it's 3, it's going to be 3 minus 1, which is 2 divided by 2 fact, and then it 1 0. Okay, Similarly here, if you want x4, you begin with k1, t to the 3 divided by 3 fact. Okay, 4 minus 1. And then k2, t to the 2 divided by 2 fact. k3, t to the 1 divided by 1 fact, plus k4. Okay, how about if you want k5, what would it be? Sorry, x5, what would it be? It would be k1, t to the 4 divided by 4 fact, plus k2, t to the 3 divided by 3 fact, plus k3, t square divided by 2 fact, plus k2, t divided by 1 fact, plus k4, t divided by 1 fact, plus k5, and then e to the m1t. Okay, does it make sense? So to sum it up, if 1m only gives you, if m is repeated p times and 1m only gives you 1k, you take that 1k, which is k1, and then you put it on the right hand side instead of 0, you can find k2. Okay, and then you take k2 to the right hand side, you can find k3, and then you take k3 to the right hand side, you can find k4, and then so on, you can find, until kp. Okay, if m is repeated p times, you need to get x1, x2 until xp. Okay, this is what you need to have. You need to have x1, x2 until xp. Okay, so let's look at some examples. First example, find the general solution for these systems of linear equations. First, we would look at the characteristic equation, right, which is a minus mi determinant of that is 0. Okay, and that is minus m, 1 minus 4, 4 minus m equals 0. Okay, we did that many times. Okay, so I'm not going to explain here in details. Okay, so to find the vector m, so we compute the determinant, so we get minus m, 4 minus m, and then plus 4 equals 0. And so here we get minus 4m plus m squared plus 4 is 0, which is m squared minus 4m plus 4 is 0. So I factorize it, I get m, 2 minus minus. Okay, so I have that m is 2 and 2. It means that m is repeated 2 times. Okay, and which is 2 and 2. Okay, so m1 is 2, m2 is 2. In the previous case, this m equals 2 gives you multiple k's, right? It gives you 2 k's. And in that case, you have 2 solutions, and that's it. That's the end of the story. But in this case, you will see that this m equals 2 gives you only 1k, and you will see how. Okay, so first we look at this equation, a minus m1 I k1 equals 0. Okay, when this k1 is k1 and k2, like that. So what we have here would be, what is it? A is 0 minus 2, that will be minus 2, 1, minus 4, and 2. And k would be k1 and k2 equals 0 and 0. Okay, so I obtained the systems of linear equations in terms of k1 and k2. So I get minus k1 plus k2 equals 0, and minus 4k1 plus 2k2 is 0. And guys, you can see, if I divide this equation by 2, I would get that equation, right? So this equation is the same as this equation. They are the same equation, right? Because if I divide the whole equation by 2, this would be minus 2, right? They will be 1 and they will be 0. So they are exactly the same. So I can get rid of this equation. I don't care. They are the same equation, right? And as you can see, we can write k2 in terms of k1. Here we can write k2 in terms of k1. K2 is actually 2k1. So we have that k is actually k1 and 2k1, right? This k1 is actually k1 and 2k1, right? Because k1 is the big k1 is k1 k2, but you know k2 is 2k1. So and then I substitute k1 with 1, so I get 1 2. Okay, and that's it, right? So for 1m we get 1k. We don't get, we don't get the case where we can't write k2 in terms of k1 and we need to split the k. We don't have that, right? We can write k2 in terms of k1, so we have only 1k. Okay, so but m is repeated twice, so you need to have two solutions, x1 and x2. Right now we have only x1, and x1 is 1 2 e to the 2t, right? 1 2 e to the m1t, right? Which is 1 2 e to the 2t. Don't forget, guys, right now our m is 2, and then we need to find x2. Okay, but before we find x2, we need to find k2. And to find k2, we need to use this equation, this one. See? Which is a minus m2i. Okay, it's actually the same m because m1 is repeated 2 times. Okay, so m2 here, it is the same as m1, right? It is just 2 basically, and then we take k2, and that is the same as k1. Okay, so basically we obtain this k1, we put this k1 in here, okay, instead of 0, right? It should be 0, right? But here we put k1 there, okay, and we want to find k2 here. Good. So from that equation, we have that minus 2, 1, minus 4, 2, right? A minus m1, m1 is 2, right? This guy is 2, right? And then we have, let's say this k2 is k1 and k2 again. So we have k1, k2, and then k1 is 1 and 2, right? Right. So we have that minus 2k1 plus 2k2 is minus 1k1 plus k2 is 1, and minus 4k1 plus 2k2 is 2. Okay, and again you can see if you divide this equation by 2, you get exactly that equation. So they are identical. So I can get rid of this equation. So I get minus 2k1 plus k2 equals 1. Okay, okay. And then I can write k2 in terms of k1 again. It will be 2k1 plus 1. So I would have that k2 is actually k1 and 2k1 plus 1. So I substitute k1 with 1. So I get 1 and 3. So we have that the second solution, x2, would be, what is it? It would be k1 t plus k2 e to the m1t, right? So in that case, it would be k1, which is 1 2 t, plus k2, which is 1 3, and then e to the 2t. Okay, so right now we can get x1 and x2. Okay, so the solution, the solution x, the general solution x would be c1 x1 plus c2. Okay, let me write it down here. Plus c2, and then x2 would be 1 2 e 1 2t plus 1 3 e to the 2t, and that's it. Okay, and guys, that is the solution when we have the repeated roots, but 1m only gives you 1k. Okay, so let me wrap it up here. First, we started with the characteristic equation. We solve for m, so we get m equals 2 and 2, okay, which is repeated 2 times. So we take 2, we find k, and then you can see that you can write k2 in terms of k1, little k2 in terms of little k1. In that case, you can obtain the vector k, the big k1, which is k1 and 2k1, and you substitute k1 with 1, so you get 1 and 2, right? Then you get the first solution. Okay, but guys, you have 2m's, so you're supposed to get x1 and x2, right? But you get only 1x. So in that case, you take the you take this equation again, but instead of 0, you put k1 in here, okay, and then you can find k2, okay, and then we get k2, which is 1 and 3, so you can get x2, which is k1t plus k2 e to the m1t. It's actually from this formula, right? k1t plus k2 e to the m1t. Okay, and it's actually this formula. And then the solution, the general solution, would be just c1x1 plus c2x2, and that's it. Okay, next example. Find the general solution for this equation. Okay, so again guys, first we look at the characteristic equation. Okay, so in this case we have 1 minus m, 2 minus 1, like that. Okay, and here the determinant is actually, you already know that the determinant is actually 1 minus m times 1 minus m times 2 minus m equals 0. Okay, if all of these are 0, the determinant is just the multiplication of the diagonal line. Okay, but if you don't know, it's okay, there's no problem. We just put the first 2 column here, so we get 0 0, we get 2 1 minus m, and then we get 0, right? And then when you multiply down here, you get this one, right? You multiply here, you get 0, you get 0, you get 0 0 and 0, so the rest are zeros, right? So here we have that m would be 1 1 and 2. Okay, so we have 1 1 and 2. So let's look at the case when m is 1. Okay, when m1 is 1, when m1 is 1, so we need to look at this equation, right? A minus m1i k1 is 0. So a minus m1i, that would be 0 2 minus 1 0 0 1 and 0 0 1, right? And that would be k1 k2 and k3 equals 0. In that case, I have that 2k, let me write it a little higher, 2k 2 plus minus k3 equals 0, and then k3 is 0. So we have these two equations, right? It means that, as you can see, you don't have k1 anywhere in this equation. It means that k1 can be anything. It can be any numbers. right? K1 can be anything because you have no K1 in the equation. It means that you don't have condition for K1. So K1 can be anything you like. Okay, okay. So if you solve this equation, you have that K3 is 0, right? So 2K2 is K3, right? From this equation. 2K2 is K3. It means that K2 is also 0 as well. Okay? Okay. In that case, we would have that K1 is K1, K2, K3, which is K1, K2, and K1, 0 and 0. Okay, here it is the same as to write K2 in terms of K1 and K3 in terms of K1, but you don't have K1 here. Okay, but you can solve for K2 and K3, so it's the same thing, right? And then you substitute K1 with 1. Okay, so here you have that is actually 1 0 0. So you get the first solution x1, which is 1 0 0 e to the m1, which is 1t. Okay, after that we can take k1, right, and we want to find k2. So the setup would be a minus a1i k2 equals k1. Okay, in that case we have that 0 2 minus 1 0 0 1 0 0 1 k1 k2 k3 is, and k1 is 1 0 0. Okay, in that case we have that 2k1 minus k2, oops, sorry, 2k2 minus k3 is 1, and k2 is 0, and k3 is, and k3 is 0. Okay, okay, this equation is from this times this. Okay, so you get 2k2 minus 1k3 like that. Okay, and when k3 is 0, we have that 2k2 is 1, which means that k2 is 1 half. Okay, again k1 can be anything. Okay, so our vector k2 would be k1 k2 k3, and that would be k1 would be just k1, it can be anything. K2 is 1 half, and k3 would be 0. Okay, and then I can pick k2 as 1 half. So I have here, it is 1, I'll pick k1 is 1, so it 1 1 half and 0. Okay, so my x2 would be, what is x2? x2 would be k1t plus k2 e to the m1t, right? So in that case it's 1 0 0 t plus 1 1 half 0, and then e to the 1t. Okay, I need to have parentheses here as well. So in that case I have x1 and x2 already. Okay, but guys, don't forget we still have another m, which is 2, right? M is 1 1 2, so we need to have x1 x2 and x3, right? So we have x1 x2, which are from m1 equals 1 and m2 equals 1, and then we need to look at the case when m is 2. So if m is 2, we need to look at the same equation, guys. Let's call this m3. I k3 equals 0. And this is back to the case when we have distinct root, right? Because the value of m, which is 2 right now, is not repeated. Okay, so we have distinct root. So in that case, we would have, what is it? What is our vector A? Is 1, 2, minus 1. So we have minus 2, 1 minus 2, that will be minus 1, 2, minus 1. And then we have 0, 1, 1. So we have 0 minus 1, 1. And then we have 0, 0, 2. So we have 0, 0, 0. And then we get k1, k2, k3, 0, 0, and 0. Okay. So in that case, we would have that minus k1 plus 2k2 minus k3 equals 0, and minus k2 plus k3 is 0. Okay. Okay. So we have that k3 is the same as k2. Okay, k3 is the same as k2 from this equation, right? Right? And so from this equation, I would have that minus k1 plus 2k2 minus k2 equals 0. I can change this k3 to k2 because k3 is the same as k2. Okay, so I have that minus k1 plus k2 is 0. So we have k2 is the same as k1 as well. It means that k1 is the same as k2 is the same as k3. So our vector k3 would be k1, k1, k1. And that would be 1, 1, 1. Right? Right? Okay. Because we can write k2 as k1 and we can write k3 as k1 as well. And then we substitute k1 with 1. So we have the third solution, which is 1, 1, 1 e to the 4t. Okay, so our general solution x would be c1x1 plus c2x2 plus c3x3, and that would be c1, and x1 is 1 e to the t, plus c2 1 t plus 1 1/2 0 e to the t, parenthesis, e to the t, plus c3 x3 would be 1 1 1 e to the 4 t, and that's it. See, it's not very hard when you have the repeated roots. If the roots are repeated and 1m can give you only 1k, it means that you can write k2, k3 in terms of k1, or you can solve for the value of k2 and k3. So if you can do that, you have only 1k. So if you have only 1k, you need to somehow put k1 to the right hand side instead of 0. Right? You put k1 here instead of 0, you solve for k2. So when you get k2, you solve for kt, and so on. And you get x, which are the solutions in these forms. Okay, and that's it. Okay, and that's it, guys, for this. Oh, by the way, we do have one more example, but I'm not going to do it here. I'll let you guys do it as a homework, and we're gonna look at that in the on-site class. Okay, so we're gonna look at that in the on-site class. I'm gonna show you how to do it, but you better try that yourself, okay, to see whether or not you understand. So guys, that's it for this section, and so we finished the repeated roots. In the next video, we're gonna look at the complex roots, okay, which is the third case. Okay, and after that we're gonna go to non-homogeneous, and that's going to be the end of this chapter. Okay, guys, I know that it's a lot to process. It's a lot to understand, but try to, try to understand, try to do lots of examples, and that will help. If you have any problems, any questions, just come and talk to me. Okay, don't forget, I'm here. I'm here to help. Okay, I am being paid for teaching you. Okay, so just come and talk to me. I'm very happy to help. So see you guys. See you next time. Bye bye.